Candace? I was like, where'd she get lost?
Have you read your great professor?
Not too long ago, yeah. Somebody really didn't like me, but
Oh, I was gonna say it was really overwhelmingly positive.
I always I always pay attention to the negatives more than anything. But like I say, if I don't get some negatives, I'm not doing my job. Because I got certain students that I only want negative reviews from.
The comment was like they did bad on every test and they didn't pass, and I was like, yeah.
All right, my favorite review was, I actually had to work to pass this class. What? Oh, that's so horrible.
Yeah.
All right, so let's do this formula sheet. I'm going to put all the formulas up here. You guys can make suggestions about what other things should be up there, and I will shoot most of them down, but you never know. Sometimes I'll forget something. So the first chapter, definitions. Second chapter, you got to know like class width for histograms like we did before. That's where they kind of bring in z-score, but I'm not going to put it first because it doesn't really come into play later. Chapter 3 is where we really saw our first first formulas.
Are we allowed to write the chapter or no?
I don't care. Because really, if it helps you, that means you're actually studying like a lot. The chapter somehow helps you. Because to me, I would remember things. Somebody would say, where's this? And I'd say, that's section 2.7. You don't have to do the same thing as key gaps, John. Probably of A or B. We got probability of A given B. And the probability of A and B is the weird one that's got two options. Probability of one times probably the other one given that guy, or probability of the other one times the probability of the one given the other guy. Number one. So remember, this is like if I draw a card and I throw it away and I go to draw another card, the next thing is dependent on what I just drew first, right? But if I put it back in, then that's the same as the probability as it would have been, because nothing changes then. All right. Okay. You know, most of you guys should have the formula sheet with us on it already, but putting all the formulas down sort of gets us back in the groove of all the shit we've done this whole semester. That's chapter 3. Chapter 4 was, uniform distribution. No. Chapter 4 was probability distribution. This business here, right? So, we've already gone through all the concepts. I've explained to you why things work. This one I actually showed you the math of how it translates. All of that stuff is great. Hopefully it made sense. But now if I give you a problem that has x and p of x in it, well then I'm gonna use these formulas because they have x and p of x in them. So I give an x p of x and people are trying to do n times p for binomial. No, it doesn't. No good. I like it. Chapter 4 also had these guys, the binomial stuff. Just trying to be an N. Still trying to be an N. You made it. All right.
Is that
Maybe.
P to the
P to the x, q to the n minus x. So really, when I write formulas on the board, it's just a reminder, and then you go look the formula up, make sure you get it written down right. You know, on the final, on any test, or the final, I guess is how you say it now, you can come up and show me your formula sheet. Say, did I write this down right? And I'll tell you, it's amazing. So that's chapter 4. Chapter 5 is uniform stuff. Big ass rectangle. No formulas. If you got to write down areas, length times width, that's a bad sign. Probably shouldn't be here. Just to be blunt. Then we get into the heart of the semester, chapter 6, where we got this guy. You got, what do we got, Jeff? I don't know, man. Then we got central limit theorem in chapter 7. Well, it's too early for that. Well, shit. Why not? Get in. So remember this. Here's a little package. Here's a little package. That kind of relates to what do you call it? Hypothesis tests, stuff like that, right? Those are the z-scores I want to use. So central limit theorem is where you first learned about what changes if I take a sample and ask about the sample mean, the standard deviation changes. Okay. And then we got chapter 8, which was confidence intervals. Yeah.
The square root of the standard deviations is the whole thing, right?
Yes. Yeah. I think I wrote sigma squared on the formula sheet for that, and people were forgetting to take a square root. Well, you should know that. Don't stop at the variance. Keep going. Let's see, that's confidence intervals. Then we got into hypothesis testing, and the only real new formula from hypothesis testing was the z-score for percentages. We didn't have that until then. So we got like z star equals p hat minus p, all this kind of business. And you got the unhatted ones down there. And then, of course, let me think. Oh, I forgot the exact same formula I forgot before. So we got one more of the chi-square, right? We put that over here. Wow, maybe. You do it, Jeff. No, not a big ass in the air. You go, buddy. I don't know why I made use of it, but I don't do it. Right, it's chi-square. That's the last new thing we did. And there is one formula I forgot up there. Same little formula I always forget, poor little dude. So evil. Which formula did I forget? No. Shit, man, there's enough up there. There's one little formula I forgot right here. Remember this guy? That's if I start with an area and you got to work back. So like if I said, what's the 95th percentile time in this normal distribution? Get the z-score, change it back into a raw score. That's the formula to change it back. So this is to go from x to z. This is to go from z to x.
Is that a
There?
Yeah.
Yeah. What's that O stand for? Observed and expected. I like it. So let me, all right. I'll let you finish copying it down. Let me know if you think there's another formula I forgot. Let me catch up with who needs some stuff from last time. Who was not here last time? Who needs like a practice final and a chi-square business? You know what the shit chi-squares you need. All of this stuff. Yeah. Oh crap. Got these now. These also. And then you need a whole nother chart. Oh shit. Did you get a practice final? You didn't get a practice final. That's fine.
Don't catch it now, but like when we're staying on our own, if we find something, one past formula sheet that isn't on this one, can we add it to?
You're gonna have to do that again for me. What?
So basically, like if there's stuff that we haven't added yet that's on our past formula sheet, and like
Well,
attach it later on.
let me know now. But obviously, you can use anything that's been on any. If you need those, come up in here and get them. I'm not gonna. I decided, screw it. If you want them, come get them. So get a copy of each of those. I'm sorry. Come at me one more time. So,
Basically, like,
what
if I catch
formula?
it later
What
on.
formula?
I don't know now.
No.
They were kind of like studying on.
Well, I said you could bring all your old formula sheets in, or you can use this big master one. Either way. So hopefully, I'm hoping that I didn't forget something, but. Oh, you can put that if you want to.
Oh, yeah.
That's up to you. That's bonus. I'm not going to freak people out that didn't even try that section. But yeah, if you did the bonus chapter 10 and you want to have that formula down, do it. But you should already know what that is. Let me also catch up with who didn't get their stuff back. Oh God, critical mass is out. Well, anybody else not get their? I got something for everybody. Oh, Jocelyn. Anybody else? Let's see. Giselle Rojas. Yeah. It's there. If you want to.
Oh, it doesn't matter.
See, I mean, that's.
It doesn't matter.
But then you can write it again if you want to with a star on it. It's the same. Or you can put a star there.
Oh yeah, I think you forgot the one like to calculate Q hat, P hat, X over N.
You got to know that. Sorry. So, no, I didn't forget. You got to know how to do that. You got to know how to make a percentage. Please. Huh? Oh, so again, if you want to write these again with stars on them, you can.
Oh, it's
Yeah.
the same thing.
It's when I use these formulas in a hypothesis test that I call them star, just to identify that those are the ones we're calculating. These are the general formulas for Z and T in these situations that I can use wherever. I put a star on them when they're in a hypothesis test. Yes, just to say that's the Z-score I made, not the Z-score of the critical region or the rejection region. Woo! All right, so I've got the answer key I'm not going to give you yet because I continuously try to trick you into doing good things for yourself. Some guys would do it anyway, but oh well, can't assume anything. So we can do whatever you want. We can do general stuff like I never understood why this or what the hell's a nominal thing, Jeff, or we can do specific problems. Yes.
My question is just about the final. How many questions is it?
Oh, how long do we have? I think we did this last time. How long do we have for a normal test?
2 hours.
Roughly 2 hours. How long is the final? It's going to be about as long as a normal test. So obviously there will be certain things that I can't put on there. Which things? Well, we'll find out when I give you the final. I'll let students tell me exactly what's the point of it. Even when I tell you what's going to be on there. I don't think I've hit 50% yet on that z-score question. Yes?
Can we just do a question like number 4, which is like the probability of percentage of Californians?
Number 4.
Probability. I'm reading off the script. Yeah, I'm gonna take the 40 points.
Oh yeah, okay. We'll do that. Let me say one thing real quick before I forget. So everybody's got this sheet now, right? On one side, it's like just about every concept we talked about in a checklist. You can use it or not. It's up to you. And the other side's got Greek letters. Yay! I might give this out. I don't know. Would this have freaked you out if I gave this to you the first day? You could handle it? Yes? No? Maybe so? All right. Yeah. Maybe I'll give it out the 5th day. And then up here is my schedule for next week, right? Underneath the one Monday, December 9th, I am going to be in that 100, 102B right there. That's my Monday, Wednesday stats class, but you know, I did my schedule not remembering that Monday was a lecture, so I'm like, this is going to be an extra review day because I already reviewed with them yesterday. After that, I'm going to be in my office from 9 to 10:30, so you can write that in. So in case you can't get up at 7, I'll be in there at 9, and you're like, 11? No, I'm going to be 9 to 10:30. Sorry. And of course, our final is the next day, so it's not a bad time to review some stuff. I like it. So, I got a request to do a problem like number 4. This is the one about getting all children insured.
Yes, and then, but also can you do the standard deviation?
Yeah.
It's far back.
Has everybody got all this stuff up here? Yes? All right. What kind of problem is that number 4 in the practice one?
Probability?
What kind of probabilities? A ton of probabilities.
Like NCX.
Yeah. And choose X. So it's what I call an NPQ problem. Right? Can you guys identify? So a huge part about any math class is identifying what kind of problem you're looking at. And I can always tell the students that are not good at that because you sort of throw a few different formulas at it and just pray, one of those is going to be right? No. So this problem, when you read it, according to a field poll, 9% believe this. Which means what percent don't believe that? The rest. So that's there's 2 possibilities there. So it must be an NPQ, a binomial situation. So can you identify for me what, for part A, because I think I changed N in part B, right? What's N in part A? 35. What's P?
0.09.
Yeah. So what's Q?
0.91.
Okay, I like that. Be real careful, guys. 9% is not 0.9. I wish my 5% account in the bank would make 0.5. That kick ass. 50% rate. Yeah, come on, bank. Make that mistake, but no shit. All right. And on part A, I specifically want to know the probability. What's the number of successes I want?
4.
I want 4 successes. So I know that the probability of some number of successes, like you said, is n choose x, p to the x, q to the n minus x. And again, the formula has to look worse than it is in practice because it has to work for everything ever. So those exponents always freak people out, but it's just one is the number of successes and the other one's what's left. Everybody else must be a failure then, right? So the probability of 4 successes, what goes here? 35 people choose 4 of them. So how many successes do I want? 4. So how many failures do I want? 31. The rest, 11. So the 2 exponents always have to add up to be n. Because you're either one or the other. All right, and then you just throw that in the old calculator. So let's see. I did bring some calculators in case you want to borrow one for today. That's all I remember how to do this. Oh, I hear it. Go. Sweet. So now I've got, let's try to put this in there. 35, where's choose? Math? Probability? Choose. 35, choose 4. Then I got to hit over to get back up to normal. Times 0.09 to the 4th. Hit over to come back down. Times 0.91 to the, what was it, 31? Good man. Y'all get that? Let's see if Past Jeff got that right. Good job, Past Jeff. Is that all right? Anytime during the final, if you get some weird error and you don't know what it means, doing whatever you're trying to do, just come up and show me. Not a big deal. Sometimes it's some little thing, formatting thing, right? Don't just sit there and go, "This is my life." Now, so part B, right? Part B.
Yeah.
I change N. What's N for part B now?
512.
512. And I want to know, all right, who's going to work today? Where's my blue? Come here, baby. The mean and the standard deviation. So what's the formula for the mean? N times P. So it'll be 512 times
439.
Yeah, 0.09. So that's the average. Because I expect 9%. So what about 512? I'd expect 9% of 512. What's that? What is it?
46.
Sounds about right.
46.8.
46.08. What about standard deviation? Square root NPQ, so square root of 512 times 0.09 times 0.91. Let's see. It's like 6 something. Yeah. So once you identify that it's an NPQ problem, you can focus on the part of your formula sheet that deals with NPQ situation. You know exactly what formulas to pull from. You're not just kind of like, please, dear God, let it be this way. Okay. Is that cool? Is that right? And then how do I find the expected, the minimax?
Taking the mean and then doing the 2 standard.
Yeah, so 2 standard deviations up, 2's down. I kind of always like to make it visual. Yeah, other Jeff. 46.08, so you just add 2 of these and you subtract 2 of those. That's what we accepted to be the minimax usual back then. When we got to hypothesis test, we went, oh, we want to control what unusual is more, because sometimes I want unusual to start sooner so that things don't blow up and people won't die. So we don't always use 2 for hypothesis tests. It's like where the rejection region is, right? Yeah.
So to find the min, you would subtract.
Yeah. So you go up 2, you go down 2. 46.08 plus 2 of these, then 46.08 minus. Let me just show you. This is nothing. If you don't like what I'm about to do, this is what I do. What I do? See how I've got. Let me do the. There's the standard deviation I did, right? No, it isn't. What did I just do? Yeah. Oh, I didn't even do it. So if I do the square root, 512 times 0.09 times 0.91, bam! You don't have to do this at all, but I just want to show you. Watch this. Times 2, store in x, and then I can just go what was it? 46.08 minus that and 46.08 plus that. Bam. All right, so that's not that exciting. Just so you know what this calculator can do, it costs enough money. And then I don't even know where to point the camera at anymore, Jeff. I don't know if that helps you guys out. Okay. Yes.
Can we do something like number 2?
Oh, the probability stuff.
Yeah.
So let's see the how many total pieces of paper do I have? 6. Right? So that's going to be my denominator for most of these things because it's going to be something out of 6 chance. So if I put all those 6 papers in a hat and I pick one out, what's the probability I get a red piece of paper? How many are red? 3 of them are red. Is that cool? Are you with me?
Where's 6 papers?
All right, we're looking at number 2, right?
Yeah.
The one about we put the numbers 3, 4, 8 on green pieces of paper, that one? So that's 3 pieces of paper so far. And then there's 3 numbers on red pieces of paper. So that's 3 more pieces of paper. That's 6 numbers in the hat. Is that cool? All right. And now you can build everything off of that. There's 3 reds out of 6 total, so there's a 3 out of 6 chance, 50% chance of getting a red piece of paper. Odd number, how many odd numbers are there? 3 out of 6, 50% again. Green and even. Yeah, 4 and 8 are even and they are on green paper. So remember, and always makes the number smaller because it's giving you more conditions to meet. Like Jeff looking through the scholarship book. Must be this and this and this. The mean bouncer. What about even given green? Given that it's green, so how many pieces am I talking about? Pieces of paper. 3. Out of those 3 pieces of paper, how many are even? So 2 out of 3. Chance. Given that it's green, so throw all the reds out. How many of those have an even? 2 out of 3.
She's like, at least I got that.
Sweet. And now number 2. What are we going to do there? Red and then green. And do you see how I put that in there? There's that hidden word. And is hidden in the English language so often. Red, then, so red and then green. What does and mean? And means?
Addition.
No. Or means that. And means multiply. So, I'm doing it with or without replacement? Without. So that means that things are going to change on the second pick, right? So the first pick, it's just everything's there. What's probably pick out a red piece of paper? Yeah, 3 out of 6. This is probably red, then green. Get at it. Become the letter G. That's close. And then, so times, how many pieces of paper are in there? 5 now. Because they didn't replace the first one, and out of those, how many are green? Still 3. And then you just do that shit. 30%.
So with replacement, it's like as if you're putting it back in like the...
So everything resets when I go to do the second pick. So then it would have still been out of 6. So part B is more interesting on that one. Probability of, what was it? 2 odds. 2 odds, Jeff. There you go. What's probably the first one's odd? 3 out of 6. All right, so I pick that one and I throw it away. Or feed it to my little brother. What's probably next one's odd? 2 out of 5. I lost a piece of paper, and at the same time, I lost an odd number. So then the top's got to change also if it's this guy. This top didn't change because I didn't lose a green here. I lost the red. I threw the red away. So and means multiply, or means add. And we actually use that idea to construct the n choose x formula. I know we might have forgotten that, but we did. Yes?
Can we do a problem like number 6, which is a high?
Oh, all right. Oh, by the way, before I forget, number 9 would be a extra credit run. I forgot that I threw that there in the middle of everything because it's got 2 samples. It would be from chapter 10. Chapter 10 was about 2 samples. Chapter 9 was about 1 sample. I made chapter 10 extra credit. So number 9 on the practice final would be from the extra credit section on the final. Yeah, in case you started looking at it. So let's see. So let's say that the average gas price last week was, gosh, I haven't filled my car up in a while. What is it at the moment? San Diego, if you don't like the gas price, wait, it'll probably get worse. 380? Shit. So we think this week it's gone up. We feel it has increased. We sample 40 gas stations and find a mean of $3.86 with a standard deviation of, what is it, Jeff? Dude, I don't know. 18 cents. Because y'all know, I mean, I look at those gas prices like in Rancho Mosquitoes or something, or somewhere, it's Carmel Valley, that's where it's always like 30 cents more. Who the shit's this person? Anyway, sir. What's the claim that's being made? Yeah, mu greater than